So let's take a quick look and let's understand how you can perform the reaction transfer from one Staad model to another. I have already briefed you about the possibilities that in which case you need to transfer the reactions from one Staad model to another, right? For your explanation, I have considered one sample problem of a building. You can observe this pre-engineering building Staad model, and another one is the RCC model where this reaction of this shelter pre-engineering buildings reaction will be transferred to this particular model, right? So that was the case. Just thought to share with you the real life examples. You can observe over here that the shelters column are with RCC cobble, right? The whole components are RCC, and on the top of that you have pre-engineering building shelter. Similarly, there is another case over here where up to certain height you have RCC column and the pre-engineering building shelter starts, right? You might have observed few engineering warehouse cases where up to 3 meter you have wall and RCC column, and over the top you have warehouse like this. So these are the real life examples, but see, depending upon project to project the situation may vary. Okay, and this one is the other case which I brief you, shelter with the pile cap. So the shelter is in PB vendor's scope, and based on the reactions that we will get, on the basis of that we will design a pile cap. These are a few field support on the pile cap, and you can observe a cutout in the FEM model, right? Now to understand this quickly, first of all, those who are beginners, I'll just brief you about the fundamental how it works, right? So all of you are aware about the analysis part, right? It's the simple fundamental rule. Whatever the loads you are applying, that will be converted in terms of reaction wherever you have provided a support, right? Let's say for this particular simply supported case, 50 kilonewton point load I have applied. So ultimately what will be the reaction? So the reaction will be distributed on these two supports, and you will get a reaction of 25 kilonewton at each support. So the simple fundamental is, whatever is the action, it has equal and opposite reaction. So that's a simple funda that you need to take care, right? So ultimately you are converting your reactions from your Staad model into the action on the RCC model. Okay, so here you are getting the vendor's file, and from that you need to convert all your reactions into action form. So ultimately your sign convention will be changed, but here there are more things you need to keep in mind. For example, the first thing that you need to understand is if the vendor has modeled that segment in the same software or in the different software. All right, here I have one scenario where vendor has modeled the segment in the different software, but the model axis are same. Let me show you over here. See, Y is the vertical, X is along the member length, and Z is along the width. These are the global axis, right? And the same, the vendor's axis I have highlighted over here. Similarly, if we talk about our Staad model, this is also same. See, along the X axis we have all the columns, means the shelter is along the length axis, this is in the Z axis. So if you are transferring reactions from here, it will be fine. That means in the simple term, if I say sign convention will be opposite. All right, that's the simple thing you need to take care. So we will ultimately convert whatever the support reactions that we have, we will convert that reactions in the form of action with the opposite sign convention, right? So the first thing you need to identify is about the model axis and the load application, right? If it is same, you don't need to worry, but if it is different, then you need to take care while converting your reactions into action form. So let's take an example of that particular shelter. See, vendor has provided this particular support reactions. 269 is my vertical reaction, and in the Z direction I am getting 53.89, right? So if I talk about in the Staad model, so this is my vertical reaction, See, 269 is my vertical reaction, so in my Staad model it will be converted into action, correct? So 269 over here, it is converted into action in the downward direction. So in my Staad model or in the RCC model, this reaction is converted into action. Now let's take another example. 53.81 is in the Z direction. Alright, so let's understand that. See, 53.81, I'll just show you again. 53.81 is the positive value. Okay, that is the reaction that you are getting. So it is, if I talk about this, 53.81 is in this direction in your vendor's model. So if you are converting this reaction into action, this will be in the opposite direction, right? So if I talk about my Staad model, here in the Z direction, it will be in this direction. You can observe the sign convention is changed. So this is the basic fundamental you need to understand about the sign convention part. If the axes are same, the global axes are same for both the models, then only the sign convention will be changed. Now let's take another example over here. Now see, this can be happen too with your segment. Now see, if you observe this, see, vendor has provided this axis. Y is vertical, X is in this direction, right? Let me draw it again. I'll erase this. See, X is in this direction, and in my Staad model, X is in this direction. So ultimately, the shelter which vendor has modeled, it is in the minus X direction. Okay, it is in the minus X direction. I'll just draw roughly to make you understand. See, it is modeled in this direction, right? The vendor has this axis, and in our Staad, it is something like this, right? So ultimately, whatever the reaction you receive from the vendor, you need to make sure that the similar reaction should convert it in your Staad model effectively, right? So let's understand this. So in case of the vendor part, if we observe, see, 88.20 is the vertical reaction. This is vertical reaction. 0.06 is in X direction. Okay, so this X is positive in this direction. So this is my X, 0.06, right? And 1.6 is minus value. Okay, so if we talk about Z, see, Z is in this direction. So here it is minus value, minus 1.6. So minus 1.6 is something like this. Sorry, I'm not able to write it properly. I'll write it again. Minus 1.6. You can understand what I'm trying to say. This is the reaction table that I received from the vendor. I'll again brief you. See, vendor has model in the opposite direction, the Staad model, let's say, and in our Staad, X is in this direction, but in vendor's model, X is in the opposite direction. Okay, so ultimately what I'm doing, I'm converting this reaction over here to just make you understand. So we will see, if you get confused about the axis orientation, just simply draw a sketch. So by visualizing this, you will able to get more idea. So what I'm doing, just to make you understand, I am conducting this in the form of sketch so that you will get a better idea. So I'm converting this reaction over here, 88.2 vertical reaction, 1.6 that is minus Z. See, for vendor, Z is in this direction, and that is the value provided is minus, so ultimately it is in this direction, right? So I have draw minus 1.6, and 0.06 is in X direction. See, X is here in this direction, so 0.06 is this. Now ultimately, if I want to convert this, right, 88.20, this will get reversed in case of my Staad model. That you need to take care. And while converting in the Excel as well, you need to make sure about this sign convention. Okay, so you will not lead to any mistake. So ultimately 88.20, which is reaction, it will convert it into action over here. Now look at the our Staad axis, so you will not get confused. Now see, minus 1.6 is in this direction, so this reaction will convert it into action in this direction. Compare it with our axis, so you will get an idea. 0.06 is in this direction, so your reaction that will convert it into action in this direction. So it is provided over here. Now I hope you are clear with the transformation of your reaction. So this is one of the most important thing. Everyone makes a mistake over here, so you need to understand simple the sign convention. Make sure about the model axis, whether it is same or it is different. Okay, I have shown you both the cases, one with the similar axis and one with the opposite axis. Now in some third case it might happen that the Z can be in the opposite direction, or it is completely in the different axis. Okay, so you need to convert that accordingly based on your reaction segment. So I hope this will give you a better clarity. Now let's understand this, how you can convert this into the Excel form. Now see, once you are clear about the sign convention, it will be too easy for you to convert this in the Staad, in the Excel program, right? You just need to play with your sign convention. Now see, in order to convert your reactions, that will be in terms of point load only or the joint load only, so you need to understand the syntax only. Why I am describing this over here? Because see, those who are beginners, for them I am explaining this in brief, in detail, right? So see, ultimately what is your syntax? Your node number and your basics 6 force and moment parameters: fx, fy, fz, mx, my and mz. Sorry, it's not printed over here, right? So total 6 parameters and their 6 values: 1 2 3 4 5 6 and their 6 values. So 6 plus 6 12, and the first one is your node number, right? So ultimately if you wish this, you just need to maintain this scenario in the Excel program and your reaction transfer is ready. Right, now let's understand this through the Excel, right? So as I brief you, I have converted this syntax into Excel program. Simple. So the first one is my node number, rest of the 6 parameters fx, fy, fz in all 3 direction, mx, my, mz in all 3 direction with their values. Now I'll convert that into Excel, and I can copy this in the Staad editor. Now let's do this in Excel. Now I hope you are clear with the direction part, sign convention part that you need to take care, and the syntax parts. Now let's quickly switch to the Staad model. So ultimately here I have my Staad segment over here, right? So just to give you a brief quickly, what I'll do, I'll go to the reaction tab over here. Sorry, I'll quickly go through the reaction tab over here. I have run the analysis. Okay, I'll go to the reaction tab. Now see, in order to print your reactions, I'll select all the support reactions. I'll go to the report tab, support reactions. Now see, keep in mind about the load combination as well. See, if you have multiple load combinations, that for each load combination you need to transfer your reaction as well. So I'll click on the support reactions over here, click on the support reaction. Now make sure all the basic load combinations that you will require, rest of the things will be taken care by the load combination itself, right? So what I'll do, I'll just convert my few basic load combinations, let's say from 1 to 14. Okay, I'll quickly switch it over here. I'll click on OK. See, so I'll get the reactions over here, or else what you can do, select all your, I'm showing you all the 2 ways. I'll just select everything. I'll go to the post processing tab, click on reports, support reaction, loading over here. You can go with all the load cases, or just go load cases and combinations, or else just go with the basic load cases. So I'll go with the basic load cases only, just to make you understand. Up to 14. Click here, press OK. So I'll get node with respect to load combination and their reactions over here. Now see, instead what in Excel what I have done, you just need to paste it over here, write this joint load over here, right? And you just need to make sure about your editor syntax, fx, fy, fz, mx, my, mz. So I have prepared all the columns over here, right? You can manually write it. Now see, to avoid a long video, I have already prepared this, but I'll brief you everything about this. So you just need to look at fx, fy, fz, just copy paste it. Similarly mx, my, mz, right? And here you just need to change your sign convention. So what I have done, I have just linked it over here, right? And you can just simply drag it over here. So it will be, let me just show you. See, I have just enter and link it over here with the minus sign. I'll just to give you a brief, I'll just give you a sample. Click here, equal to this, multiply with -1, 51.576. Similarly, you need to link all the values over here for mx, my and mz, all the relevant values. Now one thing you observe that, see, over here rest of the segment is 0, so you need to link it over here. Okay, so that too you need to link it. Why you need to link it, I'll brief you later on. See, so what I'll do, I'll just enter over here 33 again, or what I can do, I'll click over here, write down 33 and drag it till my next node, right? Similarly, equal to, you just need to make little effort only for the first time, okay? And see, I wish that you will prepare this Excel on your own, okay? And don't ask for the Excel sheet. I got a lot of comments about the Excel, sir please share Excel, but why can't you try? See, I have provided the demo over here live, so you can prepare your own Excel by simply just doing this, and it's so simple for all the cases, right? Similarly, go further, I'll click over here, I'll just link it, right? Now let's understand the magic over here. So I'll click on OK. See, because that's a node number will not appear consecutively over here, right? So I just link it and drag it, so the same node numbers will appear over here. Why I am doing this, I'll show you later on the logic behind this, because see, we need to maintain the syntax for each cases, right? So you can observe I have linked all the node numbers. So the first thing foremost, you just need to change your sign convention for fx, fy, fz, mx, my, mz, and then you need to link your joint loads. Hope this is clear, right? So next time when you paste anything over here, ultimately it will, see, this is the one time effort that you have to make to create this Excel program, right? Later on, whatever the number of nodes you have, you just need to copy paste over here. Rest of the sign convention will be automatically changed, but make sure about the orientation and the axis part. Depending upon that, in this conversion you need to make a lot of changes. Okay, now see, in the Staad portion, what you need to do, see, now we will convert the first node part. Let's say in the load case part, we will start with the dead load and live load. Okay, so I'll just show you one load. Let's say for dead load part, I want support reactions from this Staad file to my RCC profile, RCC Staad file, right? This is the RCC model where I want to convert and apply the reactions in terms of action, right? So here I'll go. Now you will see, you can apply a filter over here from here, shorten filter. Just turn on this tab, filter. Now I only want the reactions for the nodes, right? Now see, for all the nodes I need to make this, so let's first finish that. These are the nodes ultimately from your reaction tab. Okay, so whatever the number of nodes you have. Now see, another important thing I forgot to tell you, that make sure that the node numbers are relevant. I mean, what I'm trying to convey is, let me just finish this first, I'll brief you on that. Whatever the node numbers you have in your previous Staad model, make sure that number should be matched over here further. Okay, so up to 41, 42, this segment is up to 14 number, it is relevant, right? Rest of the segment is from the older Staad file or the older reactions. Okay, so I'm just simply deleting this. Okay, yes, so what I want to convey, yes, shift N. So if you observe, I'll just show you a model. See the support reaction 41, 39, 37, 35, 33. So these are the support reaction nodes. So the same node should appear over here in your Staad file. 41, 39, 37, 35, 33. Similarly 42, 40, 38, 36, 40, 34. Okay, so if you keep this node number as a similar, see currently this particular is not in a proper sequence, but what you can do, you can renumber this starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 likewise, and keep that same node number in the other Staad model. Why? Because see, whatever the node numbers you have, based on that your tab is generated over here, right? Based on these node numbers only, right? So if you keep these node numbers same, it will be easy to generate your Staad editor with the same numbers. Or what you need to do, you need to make sure that, let's say I'll go here. Now let's assume that over here my first node is 41. Alright, and in the other model my first node is node number 1. Just giving you a idea, okay? Node number over here, just assume that this is node number 1. So from 41, so see here it is 41, so you are transferring your 41 node numbers reaction on node number 1. So in Excel, while doing that, right, so in Excel while doing that, for 41 number node, here it should be written number 1, right? Why? Because the other model in that particular at same location you are transferring your reaction, over there the node number is different, so you need to change it manually over here. Now if you don't want to do that if you don't want to do this clumsy process, that's why I told you that keep the node numbers same, whatever the node numbers you have in the previous model, right? Currently in this model the node number sequence is not matched, but you can observe 33, 35, but what you can do, just keep it 1, 2, 3, 4, 5, 6, 7, 8, 9, and similarly same node numbers in the other model, right? So you just need to paste it. So this is one of the most important point that you need to keep in mind, right? Now once you finish this, see everything values are just linked over here. Now let's say you want to go with the load case 1, so I'll just filter my load case 1 only over here, click on OK, everything is linked. Now see, for all the respective node numbers, these are my respective node numbers, load case 1 is filtered and the respective joint load is displayed over here. Simply copy this, your Staad editor is ready, right? So I'll go over here, make sure about the node number. See, this is 41, here also it is 41, right? I'll go to the editor portion and I'll paste this in my dead load. Here, right, up to 42 it is. So your Staad editor is ready. Now see, there is another command where what you can do is you can join your text. Okay, tell me in the comment what is that command. What is that command through which you can join this syntax in a single text? You can do that, but anyway this syntax you can direct copy paste. Staad is considering that. Now let's check whether the reaction is converted into actions or not. See, this is converted over here. You can see that, right? Now once you transfer this, make sure about the reaction value part. I'll press Shift V and just check whether it has converted properly or not, because see, sometimes it happens that you have not prepared your Excel properly, or you forgot to add minus sign somewhere, and ultimately it will change your direction and you will lead to an error. Okay, so always make sure once you finalize your segment, right? Now it is converted into action. Press Shift V. You can change the scale from here. If it's not visible, I'll go to the scale portion, apply point force. I'll make it more visible to you. Okay, you can change the scale and the values. Okay, I was changing the moment part, but for the point load, this one is the segment. Right, so all the reactions are transferred over here. Similarly, you just need to go with the second load case. Click over here, add filter, go to second load case. So for second load case and for all the respective nodes, your joint definition for Staad editor is ready. Copy and simply paste that, right? That's how you can prepare this Excel in Staad. Now there is one another portion remaining, that is the static check. So that we will cover in the next session. So I hope you enjoy this session. Make sure about all the fundamentals that I have pointed out over here. Okay, let me just give you a quick summary over here. So the first thing you need to keep in mind is about the orientation of your Staad model. Both the orientation of the model should be same, right? You can see for this particular structure the orientation is same. If it is not same, then make sure draw a sketch the way I have briefed you over here, right? I have shown you the example with the sketch. Draw a rough sketch, try to get the identify about the axis portion, and based on that, whether you should go with the minus sign or plus sign, convert your reactions accordingly. Because see, ultimately the game changer is this portion. If you made a single mistake over here, it will lead to an error, right? So always make sure about your reaction part. All right, so this is how you can convert all your load cases like this. That's why I have considered only basic load cases, because see, rest of the things will be taken care by the load combinations only, right? So once you enter for the all the load values for your basic load cases, automatically load combinations will take care on that values, right? Another important thing, so we have discussed about the orientation of the model. Second most important thing, make sure about the node numbers which you have over here, right? Because see, the rafters first portion over here, that should be transferred to the other mod, that will be transferred from the other model to here, right? So 41 should match with 41. If it's not, if you have different node numbers, then you need to correlate your node numbers over here in your Excel accordingly. Let's say here this was 33, 34, 35, 36 and so on. Now in your other model, if it is starting from 1, 2, 3, 4, 5, change it accordingly, right? Sorry, I'll make it undo. I have filtered this currently, right? So change it accordingly over here. So at 31 location, if you have node number 1, then over here up to your basic first load case, or for all the load cases, you need to change your node numbers respectively, right? Let's say I have pasted this. So for 33 node number, these are my respective load cases and their reactions. So at 33, if in the other model my node number is 1, then I should enter 1 over here, right? Then and only then it will take, otherwise it will lead to an error. Okay, so make sure about this too, and rest of the things I have discussed So I hope you enjoyed this session. There is one check, that is the static check is remaining, so we will cover that in the next session. I'll brief you more about the manual part, how you can go with this static check, and whether, so from the static check, basically from the static check you will get an idea that whether you have transferred your reactions correctly or not. So that we will cover in the next session. Stay tuned, and remember, don't just learn software, learn concepts. Thank you.
I am definitely sure today that you have learned something different on this platform by these sessions, right? Apart from the software thing, we provide conceptual knowledge in the structural engineering. We have our social media links given in the description box. You can check out that and join us, where we will provide the valuable content every day in the form of daily design tips. We have our WhatsApp community also, you can join us, link is given in the description box. Stay tuned and check out all our fundamental course and not just the software thing from our website. Remember, don't just learn software, learn concepts. Thank you.